Good morning. Now, this is the next class, class 5, on our module radar systems. Now, in this session, we are going to discuss about pulsed radar systems, and that is about their block diagram, their description, etc. So, let us see what a pulse radar is. A radar, as the name suggests, the radar which operates with pulse signal is called pulse radar. They are broadly classified into two based on the type of target that it detects. One is the basic pulse radar and the other one is moving target indication or MTI radar. In today's session, we will learn about basic pulse radar, its block diagram and the description. And in the next class, we will work on the moving target indication or MTI radar. Okay, now this is very easy at the same. Once again, it is a radar which operates with pulse signal for detecting stationary targets. And in some textbooks, it is written as basic pulse radar, whereas in some texts, it's mentioned just pulse radar. Okay, both mean the same. It uses single antenna for both transmitting and receiving signals with the help of a duplexer. Then, what is duplexer? We will learn in the coming slides. Now here the antenna, it will transmit the pulse signal at every clock pulse, as we all know. Now the duration between the two clock pulses is taken in such a way that the echo signal or the reflected signal corresponding to the present clock pulse should be received before the next clock pulse. Okay, why it is that is done so? I have already discussed in the last class. It is just to avoid the confusion. Otherwise, if both these echo signals comes at the same time, we won't be able to locate the target correctly. Okay, now this is the block diagram of the basic pulse radar. It has a pulse modulator, then a transmitter, duplexer, antenna, low noise RF amplifier, mixer, local oscillator, then IF amplifier, detector, video amplifier and display. So this is a block diagram of the basic pulse radar. Now we will see what is the function of each of these blocks are. Here pulse modulator, it produces the pulse modulated signal and is applied to the transmitter. And what does the transmitter do? It transmits that pulse modulated signal, which is nothing but a train of repetitive pulses. Now here comes the duplexer. It is nothing but a microwave switch that connects antenna to both transmitter. Duplexer connects the antenna to the transmitter. Similarly, the signal which is received by the antenna will be given to the low noise RF amplifier, which is shown in the block diagram, and that happens only when the duplexer connects the antenna to the low noise RF amplifier. Okay. Next, what is this low noise RF amplifier? It amplifies weak RF signal which is received by the antenna, and the output of this amplifier is connected to the mixer. Now, local oscillator produces signal having stable frequency and its output is also connected to the mixer. Now, what is mixer? It can produce both sum and difference of the frequencies that are applied to it. Now, the difference of the frequencies will be, as we have already studied in the modulation chapters, it is called intermediate frequency or IF type. Now, what is the IF amplifier? As the name suggests, it amplifies intermediate frequency signal. Uh, Here, the IF amplifier which is shown in the figure, it allows only the intermediate frequency which is obtained from the mixer and amplifies. So, that is IF amplifier will amplify only the intermediate frequency. Okay, it improves the signal to noise ratio at the output. That is another function of IF amplifier. Now, what does the detector do? It demodulates the signal which is obtained at the output of the IF amplifier. Now, video amplifier, it just amplifies the video signal which is obtained at the output of the detector. Now, the display, as you all know, it displays the amplified video signal on a CRT screen. Okay, hope it is clear. Now, this is just a description of what we have already discussed. Here, the trigger source provides pulses for the pulse modulator is provided by a trigger source. Now the pulse modulator provides rectangular voltage pulses used as supply voltage for power amplifier, switching it on and off as required. Which this means that pulse modulator is just used as a switch which will turn on and off the power amplifier. Okay, then it produces a high power signal in terms of megawatt. Finally, the transmitter portion of the radar is terminated with the duplexer, which in turn will pass the output pulse to the antenna for transmission. Here, as already discussed, a single antenna is used for both transmission and reception purposes. The operation is achieved using duplexer. As we already discussed, duplexer connects antenna to transmission section only during the process of transmission of signal. Then it isolates that section and connects and get connected to the receiver section only during the reception of the signal. That is what duplexer does. That is, it will get connected to the transmission section only during the transmission of the signal, and during the reception section it just isolates the transmission section and just connect it to the reception section. Okay, now what is this reception section or the receiver section? It is a super heterodyne type. Now in that block diagram we have seen the first block is a low noise RF amplifier that actually helps to achieve a better noise figure and have another advantage of saturating for large signals, and while doing so it will act as a limiter which prevents the mixer diode from burning out of strong echoes produced by nearby targets, so that later will convert the radio frequency signal to IF or intermediate signal, intermediate frequency, and that intermediate frequency usually achieved is about 30 or 60 megahertz. Now the combination of IF amplifier and the matched filter stage will increase the output signal to noise ratio. Now the IF amplifier is broadband to permit the use of narrow pulses. That means cascaded amplifiers are used here, and they are all synchronous. That means they all can be tuned to same frequency, and they all will have identical bandpass characteristics. Finally, the output of IF amplifier is connected to a detector. Detector is nothing but a Schottky barrier diode. Here demodulation, that is retrieving the signal, is done here, and later that retrieved signal is fed to the video amplifier having bandwidth same as that of IF amplifier. The output of video amplifier is given to the detector, where it is decided whether received signal is from a target or it is just from the presence of noise. The output is finally displayed on the CRT. Now these are a few advantages and disadvantages of basic pulse radar that you can go through, and these are some of its applications. Okay, so with this we have come to the end of that session, a half session of pulse radar. Okay, so today we have discussed about one classification that comes under pulse radar, which is basic pulse radar. We have discussed its definition, its block diagram, functions of each block, and a brief description of its working, then its and in the next class we will cover the next classification, which is moving target indication or MTI radar. Okay, thank you.